सब सीडी प्लेयर्स, डीवीडी प्लेयर्स, टीवी वगैरह सब कुछ। साढ़े सात लाख।
Hello. So are we ready to go?
Good afternoon, one and all gathered here. I, Anshul Singh, Assistant Professor, on behalf of Department of Agriculture Technology, welcomes you all to our virtual conference room. The main challenge of any agriculturist is to increase productivity with limited land and minimum loss. In such conditions, precision agriculture is the only way. And also, we can say it is the future of farming. The insight on the same will be provided from an expert in this area, our guest speaker, Mr. Rohit Nandan, who is a visiting research scholar, University of Illinois at Urbana-Champaign, United States, America, and research scholar, CSRE, IIT Bombay. Sardar Patel University welcomes you, sir. Now, without wasting precious time, I am requesting to our speaker to continue the session. Over to you, sir, please.
Thank you, Anshul. Okay. Um, Now I think I got the ads here on screen. Can we go ahead? So are you able to see my screen, right?
Yes, sir.
Okay. So can we go ahead, or should I wait for some more time?
Sir, start, please.
Okay. Thanks. So okay. So as so hello everyone. I'm Rohit Nanda. Precision agriculture is the future of farming. So I will start with that point, and here I will discuss about the precision agriculture, how drone sensing and crop modeling approaches can be used in precision agriculture. What are the techniques that we in our lab, agroinformatics lab, we are using, and uh, what are the major concern about the precision agriculture which we need to focus in the future. So first, let's talk about the precision agriculture. So precision agriculture first it was started in 90s, and later people have started using the mostly the remote sensing approach for precision agriculture, remote sensing and GIS data. So what are the four R's of precision agriculture? That are the right source, right date, right time, and right place. So the right source, that means the right type of resource, even if it is fertilizer, what kind of fertilizer we should apply, and how much amount of water that is should be applied, what amount of fertilizer that should be applied, that is the right rate, right time, in which timing we should apply the fertilizer or water or other uh, other resources, pesticides and other resources, and right place in what exact location we should apply those uh, resources. So these were the four R's which were very famous and was uh, main components of precision agriculture. Later on, once recently so many new techniques have been developed, and then in European Parliament reports on precision agriculture, they redefined its definition, and again they, as per their definition, the precision agriculture is a modern farming management concept using digital techniques to monitor and optimize agricultural production processes. So here the key points are the digital farming, so which include artificial intelligence, machine learning, remote sensing technologies, big data, and Internet of Things. So basically, how to monitor the data related to agriculture production and how to process those data, those parts includes in digital farming. Then optimization of resources. How to optimize the resources, what kind of resources we need, and where and what time and in what place we should put those resources. That is the optimization of resources. That also use the data from which comes from digital farming, and the techniques, machine learning based techniques or process based uh, crop models. So those kinds of approaches it uses to estimate these four things. Now, next thing is in 2016, UN came up with one more concept that is called climate smart agriculture or sustainable production. So we need not to only think about only the 4 R's, or where we need to put the fertilizer, we need to apply the resources, and how much the time and place. We need to also worry about how much we are applying, how much we are leaving for the future, and how that will be affected by the climate change. We need to also focus on the climate. So, because if we apply more amount of irrigation, let's say, and because of high temperature, the irrigation is not that much, uh, has not been that much useful. Then we need to also focus on right breed. What kind of breed, what kind of quality of variety of crop uh, we need to use in certain locations. So that is one more concept, that is climate smart agriculture, that has also been included uh, has been included in precision agriculture. And what are the emerging technologies in precision agriculture? So yeah, so what are the emerging technologies in precision agriculture? So here, the first thing I would like to talk about the robots. So, so many farming technologies, not in India but abroad, many researchers and some farmers have started using the autopilot tractor developed by John Deere, many robots in the farm. I was in Tokyo and seen a robot that used to uh, uh, monitor the ripening of the crop. For example, it was in the tomato farm, and it used to monitor how much tomato is ripening, and based on that, it used to harvest it itself. So that kind of development, that kind of machineries or equipments are being will be there in the future, and we need to be uh, in India also we have to be ready for to accept those technologies. Next is remote sensing. So remote sensing, the most famous remote sensing techniques, that is satellite based remote sensing. So in satellite-based remote sensing, NASA has um, deployed many satellites-based sensor in the space, and uh, ISRO also have many sensors in the space. And every time, in every few months, we see the news that new satellites have been launched, and those satellites are being used in Earth observation. And the major part of observation and is the agriculture, and many research, so much research is there where the satellite-based remote sensing has been used to for the precision agriculture to decide where the farmer should apply the fertilizer or what. But in India, the condition is different from the other part of the world. Here, farmers have smaller farms, and here the satellite's resolution, which is forced resolution, cannot be used that much effectively or efficiently in Indian conditions. So it's better to use that drone-based remote sensing. So satellite or drone-based remote sensing, this is not a big deal. This uses the camera. Uh, it uses the similar approach as we have in our phone. In our phone, we have the camera. We have internet to transmit the data. The drones in drones also we can mount the camera, can even mount our phone also. In satellite also, enhanced type of mobile phone, we can say that kind of system is being used so that it can capture the data from the earth, and then using the telecommunication system we can transfer that data to the ground. So here I'll talk about the drone sensing in a bit. And then there are other technologies are field sensors networks and the IoT sensors, which we generally put deploy on the field that needs to be communicated with each other, that should communicate the information to the users. The users could be decision makers, and based on that details, that information, the users can make the decision that if they have to apply the fertilizer or not. That is one of the very effective way to put effective technology for season. Other things are smartphone applications. Smartphones have been also used uh, in the purpose of data collection as well as for the decision making. So from smartphone we can control the robots, we can control the drones, also how the drone images are being collected using the and using that smartphones, we can also collect the information like take the images of if any crop is having some disease or have some pest. That information we can collect and send it to the expert. The expert can then tell us about the what measures we should take, uh, what what are the things that we need. So in that case, smartphone is also very useful tool nowadays. Citizen culture. And other things are modeling and big data analytics. So big data analytics, because we are having the huge amount of data which we collect from all these different sources that needs to be processed, that needs to be um, used to get the information. Without getting the information from this data, we will not be able to make any decisions. So there, the role of process-based network or machine learning-based network comes in. So I will be focusing on these two things: the drone-based remote sensing and the process-based techniques. So here is the drone-based sensing cycle in precision agriculture. So here, how the drone is used throughout the growing season. So here we can fly the drone, collect the ground information related to the GB images, that is red, green, blue images, or hyperspectral data we can collect. It depends on what kind of sensor we put in the drone. So it could be GB camera, simple camera which we use to take our photographs. We can use hyperspectral camera which can have hundreds of bands, and lidar images which can give us the information about the architecture of the plant or the structure of the plant, and thermal images that gives us the temperature of the crop and can be useful to study the healthy and unhealthy crops. So all these information can be processed and can be used to prepare the treatment map. Uh, by using the empirical models, machine learning techniques, or any physical models, we can use this data, we can use the models and then get the treatment plan, treatment map. That treatment map then we can provide to the robots or any drone which can later go to the farm and then um, do the respective measures then for operations. So, for example, here this drone is spraying the pesticides on the certain location in the farm. So that kind of management practices can be done in the farm using the drones, and there are still so many things that has to be studied or examined. So yeah, drone is very powerful tool and can be very powerful in the future. So here's the some details on the crop simulation models. As you might have heard about the crop simulation models, there are hundreds of them. So many crop models are there. It is very difficult to decide which one we should use. And but based on the location, based on the data, people use different, people select different crop models and use them in their studies. So it was started from Netherlands in 1965, and so far we have so many models, and we said 4.7 has been also launched, and that has around 42 uh, models. So uh, we have done so much development in this part. And these crop simulation models can use the sensor network data, the data from sensors, the weather data, and can use the weather generator to predict the future weather pattern. And then based on this information, they can uh, come up with using the machine learning optimization algorithm, they can come up with the solution for the that what kind of management practices or strategies we should follow. So that is one way to go in the field of precision agriculture. So if after this, this was the part introduction part, and now I will explain what were our role in the field of precision agriculture. So I've been working in agroinformatics lab in IIT Bombay, and in last few years we have done some work in the precision agriculture business company. So we conducted one, we organized a conference with the help of in Indian Society of Agriculture and Information Technology. And the conference name was AFITA WCC 2018. It was inaugurated by Honorable Vice President of India, Sri Venkaiah Naidu. And the title of the conference was Research Frontiers in Precision Agriculture. This was international conference, and people from all over the world, from Indian institutions came and discussed their ideas about precision agriculture. So um, it was my privilege to be part of this conference, and I was in board method committee. We combined and edited all the papers and published it. And okay, so I think someone drew on the um, page. Okay, if, I think someone drew on the page, so if they can remove it, that would. Okay, I will keep going. So other than that, we have been also publishing some work in different as a part of different book chapters other than papers in the precision agriculture and drone-based sensing. So other than this, we have a project that is called this data science-based farming support system for sustainable crop production under climate change. So that is the DSFS project. So it's very big name. So we call it DSFS project. The aim of this project is to uh, establish a joint lab uh, for research to support the climate smart agriculture. So this in this project, the Japanese science and technologies and from India side, DST is uh, funding this project. And Achal,
Yes, sir.
so there are some drawings on the screen. So can you ask someone to remove it?
Yes, sir. Sorry, sorry. जो भी स्क्रीन से छेड़छाड़ कर रहा है प्लीज मत करें, प्लीज. Okay, sir. Continue.
Okay, thank you. So yeah, so in this part, so in this project, the University of researchers from the University of Tokyo and the IIT Hyderabad, IIT Bombay is playing the lead role. Uh, with that, IIT IIT Hyderabad and the university from Professor Jasankar Prasad, Telangana State Agricultural University, that is also helping us, and our research farm is established in their farm. So we go there and collect the field data from there. So these five institutions are directly involved in this project, and University of Illinois, Monash University, and recently three international organizations indirectly involved in that project and giving their uh, mentoring the project um, in some respective fields. So this is the farm which is located in uh, the agriculture universities. These are different plots which have different treatments. So here each number is representing certain treatments. I should put those treatments here also. Um, I think it would be fine. So it is located in semi-arid region in Hyderabad. The main purpose of this project is optimal crop management. The focus crop is for maize. Uh, we have deployed multiple sensor networks. So University of Tokyo and University of Hyderabad was the one who took that role for deploying the sensors. IIT Bombay was playing the lead role in collecting the drone sensing data, RGB, as well as hyperspectral images and the field sensing data. So this is the optimal crop management. This is the one component of this project where there are sub components. One is crop identification and management. Another is weather-based crop resource management. The uh, objective of this crop state identification and management, where we are using the drone sensing and drone-based uh, data images, that the objective of that is to develop a model which can identify water and nitrogen. So here we are collecting different data, different parameters on the field, leaf area index and canopy temperature. We have the field instruments to collect that information, and then drone-based hyperspectral and RGB images that we are collecting from the using the drone. So hyperspectral is a very big camera which has can give us the data in multiple bands, around 100 or 200 dimensional data we get using the hyperspectral uh, images. RGB, that is the red, green, blue images. That is no, that for that we are using the normal camera. Uh, Leave hyperspectral signature. We also have the handheld hyperspectral signature collecting device that we call it spectroradiometer. So from that we are collecting the samples of the hyperspectral signatures of the leaf. Also, we take that leaf and do the destructive sampling, and then later on we uh, go to the lab and then analyze it and collect some of the uh, chemical uh, contents from those leaves. So that part is done in the chemistry. Then crop height, leaf angle, and some other parameters that these things are.
Sir, excuse me, sir.
Yes, yes.
सर यहाँ से वो स्केच नहीं रेज हो पा रहा है, एक बार आप ट्राई करके देख लीजिए कि स्क्रीन आपने शेयर की रखी है।
Okay. I can stop sharing and then again start sharing.
किसी से बाय मिस्टेक हो गया है सर, चलिए।
Okay. Now I can start.
थैंक यू।
Okay. So this is the way how we are collecting the spectroradiometer data. We have this handheld instrument. From that we collect the spectroradiometer data. We take that leaf as a in the lab and dry it for 72 hours, then make it in the powder form. Then we use the CHNS analyzer, and using that we uh, get the chemical contents of that leaf, the nitrogen, carbon, hydrogen contents, and based on that we prepare a table and with the information, of course, from the carbon spectrum. So after this data from this we develop a model, and that model help us to estimate that certain chemical content from the drone data. So that I'll talk. Uh, so here this is the drone which we are using, AGI mattress 600 hexacopter. It has 6 wings, and the payloads which we are using is hyperspectral imager and RGB camera. This is the Canon camera, which is programmable camera, where we programmed this camera and put it in the drone and to connect it. So to handle this drone, to select, to operate this drone, we need to first select the platform. So here in the PC, we select the platform and upload that platform to the um, smartphone. And using that smartphone, then the drone is operated and being used on the platform. So how this drone sensing is different from satellite sensing? And so I will be talking here in the form of the data collection, how that will go through them and acquire the data, and what are the corrective measures we do to correct the image. So here is the satellite, passive remote sensing satellite that depends on the sun, and this is the surface reflectance, this is ground reflectance, and then top of atmosphere radiance. So because there are so many particles in the atmosphere, so whatever reflectance that is there in the ground, that will have so many noise um, when it goes near to the uh, sensor, the satellite sensor, and then the satellite collects the data in the digital. So to correct the images which we get from the satellites, we first need to do the radiometric correction, because we need to collect the data with the surface reflectance, like not in the form of digital numbers. So from this surface reflectance value, we can do some of the analysis, not from the digital. So first we do the radiometric correction, calibration, then atmospheric correction to remove the atmosphere effect, effect, and the PRDF correction. So these corrections are required in satellite. In the drone, in the case of drone imagining, so it also depends on the solar radiation, surface reflectance, and count radius and DN number. So it doesn't have a thick layer of atmosphere between the sensor and the ground. So for this, we need not to worry more about the atmospheric correction. We need to check with the radiation correction. And that in atmospheric correction we need to do if there is a cloudy condition and the sun solar radiation intensity is low, other than it is not required, then we are doing correction. So after the correction we get the image like this. So here is the image of uh, funnel. So in this image, the other correction that needs to be done is the missing line correction. So here, sometimes what happens that if drone is there in, if it is flying, then because of the wind, it can taken away few meters if there is a high wind. And because drone is GPS operated, so it will try to come again. It will try to come on its own path, the original path. But GPS may not be that much accurate, so it may miss some of the information, and that is the reason why we are seeing here this missing lines. So that missing lines may not be that much. If they are not that much, then we can take the average of adjacent layer and fill it, and that is the one way to uh, go with this missing lines. But if there are two numbers of missing lines, then it's better to apply the tone again, because we might be missing a lot of data, a lot of information because of those missing lines. Other than that, the another process of processing the uh, images on drone is the image stitching. So we get the data in different tiles form. So type 1, tile 2, tile 3, tile 4, and tile 5. These are different tiles which are collected from the drone images. Now, using the softwares, there are many software. We need to just upload these images, like Pix 4D is one software that we use and that is still image. So like this, we get the data of the whole farm. So this is the then arithmetic of the staged full form data. This is the our research farm, and this is the each plot where the particular treatment was applied. Now here, if we see these are the uh, horizontal and vertical views of the farm which were created using the RGB image dataset software. So these images can be created using the point clouds, and from that we can get the DEM. DEM is the digital elevation model, which gives us, using that digital elevation model, we can then estimate the height of the plant. So that is very important to estimate the height of the plant. So, any questions? If anyone has any questions, then I will be happy. Shall I go ahead?
Yes, sir.
Okay, thank you. So, other than crop height, we are also collecting the leaf area index. Leaf area index that gives us the information about the density of the crop, how much dense the canopy is, and the chlorophyll content. These two parameters are important because from that we from these parameters we can get some idea that how healthy the crop is. So we use the drone sensing data and then processed it and analyzed it, and then found these maps of LAI and then the tassel counting. So one of the major growing stage of the maize is tasseling stage, and the number of tassels that matters because that can be used to can be used and give some information to predict the crop yield also. So here we used the two machine learning approach. One is faster RCNN. This machine learning techniques were used on the RGB data, home-based RGB data, and faster RCNN, that is also called ResNet 50, and Dolo version 4. These are two recently developed machine learning approach, and both were able to identify the tassels on the farm. So these uh, blocks, green and here um, the purple kind of blocks, they are the tassels which are detected using this machine learning approach. And to check the performance of them, to compare them, they both performed very well, and they both, so there was not much difference between these two. But we also use the hyperspectral band. So we used one band, and this is the hyperspectral band. And we found around precision here is 97.7% to count the tassel and count the tassel, and here the precision is around 88%. So it's still the hyperspectral band here it gives it has more information than the here we need to use the different machine learning approach to count the castle and here we do not use the any machine learning approach. We need to only use the image and the basic numerical methods will work on the test. Then we use the hyperspectral data to estimate the leaf quarter. So this is how the hyperspectral data looks like. Here are multiple bands of this hyperspectral data here. So it is representing that each of these blocks, how it will look like in the form of in the linear way. How it will look. Here it is showing how this object will look. And using this, and then we created the heat map using the R square between these problems. And we found that if the R square value is high, then we selected those indices to use it for the leaf water content estimates. So we use here these three indices which we selected from earlier analysis, and we also use the eight indices which are already developed and we have taken them from the literature. We combine these indices, then we use the supervised and supervised classification approach, and after that we got the classified map like this. So in this, the red color is from the water stressed uh, pixels, and green is from non-water. So all these techniques have to be improved more, but so far we are able to understand if number of pixels here, we can count the number of pixels here. If number of pixels of water stressed pixels are more, then we can provide the irrigation. So these kinds of analysis will be very helpful in the future for the irrigation scheduling of so far, using the drone-based sensing and machine learning approaches, we are able to estimate the leaf water content, leaf area, and chlorophyll content, crop height, and test. And we are uh, working on to estimate the nitrogen content and to predict the crop yield using the drone sensing. So this was the first component. The next component here is the weather-based crop resource management, which is uh, which is based on the climate responsibility. So here the objective is to develop a method for optimization of water and nitrogen use in the climate variability countries. So we have so far worked on the irrigation scheduling or water management part. So and the nitrogen management part is still is under in progress. And so here I will present only the water management. So here the research questions, the major research questions are that how does corn respond to the precipitation variation, elevated CO2 and temperature conditions. So basically how the corn yield will respond to the climate change. Then the second question would be in what extent the water and nitrogen management can offset this negative impact because of the climate change. So that focus is on the climate responsibility. Then what is the best method to optimize the water and nitrogen? So I am working uh, on these research questions on ABI experimental Park, which is located at University of Illinois, USA, and also in ARI experimental, which is in India. So this is the modeling framework which I am using. So here this is the um, engine of the model where the major numerical numerical simulation is being done. This gives us the photosynthesis rate that we can convert into carbohydrate assimilation, and that then will be used to simulate the crop yield as well as the LAM. Here I have also incorporated the irrigation strategies. So I will talk about this. So here is the farm where I am focusing on corn, soybean rotation, only this farm. Here we have the weather data, observed weather data for these 4 years, which I used for the evaluation of this model. And here is the evaluation data, the above ground biomass um, between the simulated and observed, the above ground simulated and observed biomass. So here we could see that the model is performing well. Only in 2011 case there is some gap. Otherwise, the simulated biomass is following the lead of observed biomass. Here is the result of LAI for 2009 and 2010, which is pretty much close to the observed LAI, and it is giving the high accuracy and only error of 0.47. And here in the case of 2010, it is giving the 0.6. Then I analyzed uh, the then I used that model for the purpose of irrigation scheduling. And for that, I have generated the climate change scenarios using the weather generator, then simulated the impact of climate change using the MLCAN model, which I discussed earlier on profit, then identified the dry years, and then applied the irrigation scheduling on dry years, and then examined the role of irrigation scheduling, and which are the so what are those irrigation scheduling methods which perform well in the climate. So here is the weather generator which I used, published in 2011. So the climate change scenario was generated based on the climate model results. So here if we see the precipitation change can be seen up to 25%, around 23 or 25%. So that was one formation that we took from climate models. Here is the global CO2 change that was that will be in 2050, that will be 50. This is the change in temperature that varies between 1, 2, and 3 degrees Celsius. Based on this, I have generated the climate change scenario. So here we can see in present condition, the CO2 concentration will be 400 people, and in future condition, that will be 550. Two levels of precipitation change I have considered. One is no change, and another is 30% reduction. And two levels of interseasonal precipitation variability, that is no change, and 10% increase in precipitation variability, and three levels of temperature. So after simulating the model for all these scenarios, it was found that temperature has the enormous effect on the uh, crop yield. So it can reduce up to 40% of the crop because of the temperature. The other parameters like precipitation that also affected the profit. It has reduced up to 20% of profit, but with 3 degrees Celsius temperature change, overall we can see that 40% of profit. So then we identified the dry years using the dryness index, and then applied these three irrigation scheduling on the um, on the this model. So after applying this irrigation scheduling method, it was found that leaf water potential is giving a good result. So it can improve in the up to 40% of crop. And only in the case of that scenario number 10, the other methods like water balance, crop water stress index are giving the higher than leaf water potential based irrigation scheduling. But in all the other cases, it was found that the water is potential is the most effective method. If we see the irrigation water use efficiency, which tells us about the efficiency of particular irrigation method. So here you could see that in almost all the cases, the leaf water potential was found most efficient. So from this, we can say that climate change negatively affect the profit and can cause up to 40% reduction in profit. And deep water potential can be the most effective as well as efficient method of profit. listen, and it can be used as a climate smart farming method for waste irrigation schedule. Here, other than that, in future, I'm planning to investigate the methods to optimize the nitrogen application. So I'm presently working on developing the model for nitrogen and to um, um, I'm developing a model which can deal with the nitrogen dynamics. And then I will use the same MLCAN model or and some other models. So presently, I'm thinking about PSET or FSET. So I will use those models in Indian conditions. So then use the similar approach to study the impact of climate change as well as to study the optimal impact. Other than that, our last focus was and our last objective is development of on-farm DSS for optimal crop management. So we have already started working on it, and we are developing a web user interface where um, the information from drone sensing as well as the climate smart farming can be linked together and can be combined used to make the decision agriculture decisions. So thank you everyone. And if you have any queries later, you can contact me on my email or contact me on LinkedIn. So if you have any question, I will be happy. Thank you.
थैंक यू वेरी मच सर, वेरी मीनिंगफुल इन्फॉर्मेशन यू डिलीवर टू अस। जैसा कि मैंने पहले ही कहा था कि प्रिसिजन फार्मिंग हम इसको फ्यूचर ऑफ फार्मिंग भी कह सकते हैं, जैसा अभी हमको सर ने समझाया। तो अगर आपका इन सब से रिलेटेड अभी जो हमने समझा कोई भी क्वेश्चन है, कोई भी क्वेरी है, तो अभी आप पूछ सकते हैं, या फिर अभी आप पूछने में हिचकिचा रहे हैं तो सर ने मेल आईडी दे रखी है, उस मेल आईडी में भी आप क्वेश्चन कर सकते हैं। एनी क्वेश्चन? हाँ राजकुमार।
Yes, ma'am. So, what is leaf area index and why it is necessary to
Yeah,
calculate leaf area?
So leaf area index tells us about the density of the canopy. तो canopy कितना dense है? So अगर canopy ज़्यादा dense होगा, then we can say that plant is healthy, right? और canopy थोड़ा कम dense होगा, तो उसमें बोलेंगे कि plant healthy उतना नहीं है। ऑफकोर्स जो ग्रोइंग सीजन है वो भी इम्पोर्टेंट है, क्योंकि जैसे जैसे ग्रोइंग सीजन बढ़ता जाता है मेच्योरिटी के बाद जो प्लांट की डेंसिटी है थोड़ी कम होने लगती है, तो दैट इज आल्सो इम्पोर्टेंट, सो दोज इंफॉर्मेशन इज नेसेसरी, बट लीफ एरिया इंडेक्स कैन आल्सो प्ले इन द मेजर रोल इन द modeling. So if we need any information related to for example how much crop yield is going to be, then also leaf area index um, can play a big role.
Yes, sir.
और कोई? Any
Sir,
query?
leaves. Yes, ma'am.
Yes, Raj.
Hyperspectral signature. What is leaf hyperspectral signature?
Yeah, so spectral signature, do you have course on remote sensing? Okay, I'll talk about it.
सर एक्चुअली ये बच्चे थर्ड सेमेस्टर में है, सॉरी थर्ड ईयर में है, फिफ्थ सेमेस्टर है, तो अभी इन्होंने उतना पढ़ा नहीं है रिमोट सेंसिंग के बारे में।
हाँ, तो रिमोट सेंसिंग में जो सबसे पहला चैप्टर होता है वो होता है स्पेक्ट्रल सिग्नेचर के ऊपर। उसमें इंफॉर्मेशन होती है कि कैसे रिफ्लेक्टेंस जो एक टर्म है, क्योंकि जब भी कोई रेज आ रही है सन से, ठीक है, वो किसी बॉडी से ऐसे टकराती है तो वो रिफ्लेक्ट करती है उस रेज, ठीक है, उसी को जो रिमोट सेंसिंग इंस्ट्रूमेंट है वो कैप्चर करता है। तो जो रिमोट सेंसिंग इंस्ट्रूमेंट जब कैप्चर करता है तो वो इन द फॉर्म ऑफ किस कौन सा बैंड है उसके अंदर, सेंसर किस बैंड का सेंसर है, सिर्फ उसी बैंड का इंफॉर्मेशन कैप्चर करता है। तो यहाँ पे देखो ये सिग्नेचर्स है, सिग्नेचर्स मतलब कि ये वाला सिग्नेचर जो ऐसे गया है ये किसी एक पर्टिकुलर वेजिटेशन का होगा, ठीक है, जहाँ पे ये ग्रीन 500 to 600 जो रीजन है, तो ये रीजन है ग्रीन स्पेक्ट्रम। तो हमें वेजिटेशन ग्रीन क्यों दिखता है? वो इसलिए दिखता है क्योंकि जब ग्रीन लेवल में, इस लेवल में द रिफ्लेक्टेंस ज्यादा होता है, प्लांट ज्यादा रिफ्लेक्ट करता है, ग्रीन स्पेक्ट्रम को, ठीक है, रेडिएशन। तो इसीलिए यहाँ पे हमको ग्रीन में हायर रिफ्लेक्टेंस मिलता है। तो यूजिंग ऑल दिस इंफॉर्मेशन, ऑल दिस सिग्नेचर इंफॉर्मेशन, we analyze it and based on that we make the decisions.
Yes. Sir, how can we calculate the chlorophyll content of a plant through remote sensing instrument?
हाँ, so इसमें NIR band, so this is the NIR region, near infrared region. तो ये रीजन बताता है कि प्लांट कितना हेल्दी है, राइट। तो अगर प्लांट हेल्दी कम होता है तो यहाँ पे रिफ्लेक्टेंस एकदम कम होगा, और प्लांट अगर अच्छा हेल्दी है तो यहाँ पे रिफ्लेक्टेंस ज्यादा होगा। तो बेस्ड ऑन दैट और बेस्ड ऑन द इंफॉर्मेशन दैट वी हैव फ्रॉम द ग्राउंड, ठीक है, तो दोनों का कोरिलेशन देखते हैं और कितना ज्यादा इन दोनों के बीच गैप कम या ज्यादा है, उस बेसिस पे हम निकाल सकते हैं क्लोरोफिल फिल कंटेंट कितना होगा। इसमें भी और भी बहुत स्टडी होना भी बाकी है, ठीक है, मतलब एग्जैक्टली हम लोग बहुत ज्यादा एक्यूरेटली नहीं बता सकते कि कितना होना है, कितना होगा क्लोरोफिल कंटेंट, बट वी कैन गेट सम एस्टिमेट दैट द क्लोरोफिल कंटेंट would be around this much.
Sir, we can only estimate the that which plant have more chlorophyll content. We can
Yes,
compare
that,
that. Yeah.
yeah, that also we can get. So that information, so based on this, if the spectra in spectral signature in this region will be high, that means that is the healthy plant. In healthy plant we assume that the chlorophyll content could be high. So because here the reflectance is high, so that is the reason also for, because that is so that depends on the structural property of the leaf. So because of that, here the reflectance is high, right? तो वो क्लोरोफिल कंटेंट की वजह से ही यहाँ हाई मिलता है, अगर वो कम होता है तो यहाँ पे लो रहता है। Yeah.
Yes, sir.
So you are muted. Yeah. Okay.
और कोई क्वेश्चन?
Any other questions?
Okay, then now I would like to call Mr. Zaki Sheikh, sir, Head of the Department of Agriculture Technology, for vote of thanks.
Good evening, everyone. I am honored to and lucky to have the opportunity to give a vote of thanks on this special day. I particularly liked Mr. Rohit Nandan's speeches, where he mentioned the advantages and need of precision farming in this seminar. The way in which he explained this subject was extraordinary and fruitful for our participants, especially for our student. I would like to thank organizing team, staff members and students. Finally, I want to thank respected Vice Chancellor Dr. Sudhakar Singh, Director School of Agriculture, Science, Technology and Research, Dr. Navneet Satankar, and Head of the Department of Agriculture Science, Mr. Avdesh Chaudhary, for their support and guidance. I would like to thank you again for making this event a success. Thank you so much, Rohit sir, and will be thankful forever.
Yeah, thank you so much for this invitation. It was great privilege from my side also to be here. Thank you.
Thank you, sir.
So if you, all of you, if you have any questions or any query, you can contact me. We have, because this time is very difficult for all of us. This pandemic situation is making that things very difficult to go on. But during this time, we have got a lot of research interns from different institutions, mostly the uh, BTech students. So who are working with us at IIT Bombay, and they are working from home, but we are guiding them to use the how to use the data, how to use the drone sensing data in for making the decisions. So all this type of work is going on and being done by research interns. So if anyone is interested, then yeah, and we they can contact us. Thank you.
Thank you, sir.